And the teacher told me, hey, when I look at this, the book says that this number line really should represent 4 minus -6. And that's what the book says. It says 4 minus -6. And I'm a little bit confused why this or how this number line actually represents this. And in that conversation, the teacher asked me, sometimes students ask, hey, why is it that to subtract a negative we add its opposite? Why does that rule work? And I've been working with students throughout the years and giving them different answers, but I still feel a little bit confused by this. And in fact, there's a problem in our math book that confuses me every year that I get to it, and I'm really not sure how to respond to students to help them understand this. So I asked, hey, would you mind showing me that problem? And I don't remember the exact problem, but it looks something like this. We have this number line, and we're seeing some addition, some subtraction, kind of see some arrows and some dots. And I asked the teacher, hey, what's going on when we look at this? When we're looking at the problem, what is it that you're confused by? And the teacher told me, hey, when I look at this, the book says that this number line really should represent 4 minus -6. And that's what the book says. It says 4 minus -6. And I'm a little bit confused why this or how this number line actually represents this 4 minus -6. So I took a look at it, and to be honest with you, when I looked at it, I was a little bit confused because I'd never actually seen it written like this before. And I looked at it and said, I'm not really sure. I do see there's a -6 happening here. There's a 4 here. To me, I'm a little bit confused about, okay, isn't this like 0 take away 6? So maybe this is going to be like starting at -6. How much do I need to get to 4? But I'm a little bit confused by this 4 minus -6 myself. And to be honest with you, when I started looking through the rest of the book, I got a little bit more confused. I thought, hey, maybe this is a misprint. Maybe there's something wrong with this. Let me take a look at the rest of the problems. So when I looked at some of the rest of the problems, here's what one of the other problems kind of showed us. Is looking into this, one of the other problems that we had showed this. There's another arrow happening here. And when I looked at the problem, I said, okay, so how can I use this number line to make sense of adding or subtracting negative numbers and such too? So when I looked at the book, looked at the teacher manual, and pulled this out, I saw that this number line here is supposed to represent -3 plus, what was it? It was going to be -3 plus 1, 2, 3, 4, 5, 6, 7, 8, plus 8 equals 5. This is supposed to kind of show that that's -3. So we kind of start at 0. Our initial point is -3. So this kind of shows that initial point. I don't love that arrow being there. I kind of wish we just kind of started at -3. But I get it. That's fine. I kind of see how that works. So then -3 plus 1, 2, 3, 4, 5, 6, 7, 8. Sometimes we even kind of do like bouncing over kind of these bouncing curves, kind of looking at this 3, 4, 5, 6, 7, 8, looking at that. So -3 plus 8 is 5. And to be honest with you, that's okay. I'm cool with that. Again, I'm not sure how I feel about that little pink arrow there, but that felt good. So then I went and said, okay, what's the next number they have when they're looking at this? The next number line they had. And the next number line they had was this. Again, looking here, when I looked at this particular problem in the teacher guide, what they recommended this one would be is kind of my starting at 0, my initial point is 3, so I kind of move to +3. And then I'm moving left on the number line, so moving left on the number line is taking away. So taking away 1, 2, 3, 4, 5, 6, 7. Taking away 7 is -4. And this is a good visual understanding, a visual way to describe that 3 take away 7 is -4. And to be honest with you, I like that. That feels pretty good. Again, I don't really love the pink arrow there. I would have just kind of said start at +3 and subtract 7. So again, that felt pretty good to me. So then I went ahead and said, okay, let's continue to see. Maybe I'm missing something in the book. And another example that we had was coming into this piece saying, okay, what does this number line represent? And looking at this number line when we're seeing, okay, what does it represent? Kind of seeing here, again, kind of starting at 0, but really our initial point is I go from 0 to get to -2. So here I'm at -2. Take away how much? So take away 1, 2, 3, 4, 5, 6, 7. So -2 take away 7, or -2 minus 7, I guess we should probably say. -2 minus 7 is -9. It's a nice visual way to explain why subtracting positives and negatives works. Using a number line is a great way to do this. I've recommended using number lines for years. I've seen it really work well with both teachers, with students, everyone kind of understanding this, as opposed to just the visual, like kind of imagining what it looks like. So this is a really good way to explain this. So then I went back to the original problem that we had, and the original problem we had was this. Going back over to here, and I'm just thinking to myself, hey, I'm confused by this, because that original problem still says, okay, so I'm like my starting point, according to the other rules we're looking at. So my other pages, like again here, shows me the starting point is negative 3, and the endpoint is 5. We're looking at this. So in this case, my starting point should be negative 6. And then I'm ending at 4, so this should say negative 6 plus what is 4. At least in my eyes, that's the way I looked at it. And to be honest with you, when I looked at this, I thought, hey, that's a misprint. But then I saw a few more number lines written in exactly the same format, saying that it should equal something like here. And I moved away from it being, hey, I think it's a misprint, which happens. I get nobody's perfect. We see misprints. But I moved away from that to being frustrated and to even be thinking, hey, this is a really dumb way to explain this. This is just overly confusing, and it really doesn't make any sense. So I kind of turned to the teacher and said, yeah, I think it's just a misprint. I'm not sure what they're going for here. I'm not sure what their goal is when they're trying to say this is 4, take away negative 6, because that feels so very different than when I kind of started here and ended here. I just don't see this, and I was confused, and I kind of set it off to the side, and we got talking about something else and moved on. And then I said, you know what, let me take a look at your teacher guide again, because I'm not feeling very good about that. I don't think my answer of just kind of pushing it off is a great way to do this. So I want to lean into this a little bit. So I actually went to a few pages even earlier in the teacher guide, and I kind of saw that the next number line that we're going to look at here, and that next number line, as I'm processing through here, that next number line looked like this, and that next number line was looking through this and saying, okay, actually I guess it's the previous number line we saw. So when they were introducing this concept earlier in the textbook with the students a couple days earlier, that I wasn't in the class, so I didn't see this part, they kind of said, okay, some couple different ways we could look at this. This could be starting with 3 and then adding a certain number to get 8. So that's one way we could look at it. So kind of our initial value is starting at 3, and then how much do we need to get to add to 8? And I've been looking at that saying, okay, if this is my starting value, 3 plus 1, 2, 3, 4, 5, this is 3 plus 5 is 8. And that's the way I've been looking at each of these number lines. But then the book showed something a little bit different. The book presented a question saying another student said that this particular number line could represent something a little bit different. And I want to talk about that just for a minute, because another student said that we could represent this and saying, okay, 8 take away 3 is what number? And I really wasn't sure what to think about that for a minute. So 8 take away 3 is what number? A student, according to the textbook at least, looking through here, a student asked, or kind of said that they think this number line could be that. And I want to process that for a minute, because at first I read it and I'm not really sure what that means. But now if I look at this and see, this could be 8. So 8 is still kind of like my end point. Looking at this is my difference as I'm thinking about this process, or my sum, however I want to process this. So really I'm ultimately asking, is 3 plus what number is 8? Well, another way we could think about this, thinking of this as a difference problem, is 8 take away what we've already used. 8 take away 3 is going to be what number? And really, 3 plus 5 is 8. 8 minus 3 is 5. Those both work mathematically, and it's a flexible way of processing this. And I was beginning to think, hey, I always talk about being flexible, so can I myself be a little bit more flexible? And trying to figure out, okay, how could that possibly relate to that other number line we had earlier? And I'm going to get back to that in just a minute. But what I wanted to kind of think about is really what I'm doing here when I'm kind of doing this is saying, this is kind of thinking additive. 3 plus what number is 8? That additive idea. So I'm going to kind of write that here and think, okay, this first one in black is like additive. Kind of what two numbers add together to get 8, or what am I adding to 3 plus what number is 8, or 3 plus 5 is 8, looking at this. But then this one here is kind of thinking about like subtractive, or I'm going to think of this as like the difference. There's a few different ways we could say this, but I'm thinking about this, what's the difference of 8 and 3? And we use that word difference a lot, and we say difference means subtract. But in this particular case, I'm looking at this as the difference of 8 and 3 is another way to think about that. That difference of 8 and 3 is how much is between those two values. So what's the difference of 8 and 3? The difference of 8 and 3 is how much is here. That difference is, there's 5. The difference of 8 and 3. The amount of space between 8 and 3 is 5, and that's that difference thinking about this. So then I went back over to the other idea and thought, okay, could I think of that difference idea over with this other number line? So looking at this, because I do actually see subtraction here, and I'm beginning to think about difference, thinking about what do we have here? What could this be about difference? So if I think about this, if 4 is my end point, sort of like 8 was my end point over here, that black dot. If 4 is my end point, what's the difference of 4 and negative 6? What's that difference? So thinking about here, what is the difference? Is the difference of 4, oops, that's a misspelling there, sorry about that, of 4 and negative 6. What's the difference of 4 and negative 6? And I could keep that, but I'm going to go with my growth mindset and say we all make mistakes. That's cool. What's the difference of 4 and negative 6? And really what I'm asking there is what is the difference? How much space is between 4 and negative 6? So thinking about this, what is that difference here? And this difference, if I go into this, this difference is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The difference of 4 and negative 6 is 10. The difference of 4 and negative 6 is 10. And thinking about this contextually, now I'm beginning to think, hey, wait a minute, I kind of like this number line. I like the way we're explaining that, how I can process this. So I could think of this the way that I initially wanted to, and I was thinking, hey, this is going to be negative 6 plus what number is 4? Negative 6 plus 10 is 4. I could think of it like that way as an addition problem, but I could also think of it as a subtraction problem. And this idea of 4 take away negative 6 really is thinking about really not just take away, but what's 4 minus negative 6? Another way of asking that question is, what is the difference of 4 and negative 6? And when I'm thinking about the idea of the amount of spaces on a number line, just like, again, coming back over to here, with this more whole numbers, or I'm sorry, positive numbers, what's the difference of 8 and 3? The difference of 8 and 3 is 5. So we're thinking of that as a subtraction problem. And I'll be honest with you, the more that I've thought about this, it's now been about 4 days since I had this conversation with the teacher. The more that I'm thinking about this, the more I'm thinking, hey, I really like the way the book did kind of show that. I really like the way the book explained how we're thinking about, okay, this could be thought of as a difference problem. And to be honest with you, I've always used counters, red and yellow counters, or I've talked about things, maybe elevators, and thinking about different ways of saying, hey, like the opposite of something. We talk about that a lot. But I really had never seen anyone explain it like this before. And I think this is an interesting way of kind of developing our own thoughts and saying, okay, do I understand what difference means? Difference doesn't always mean take away. It can mean take away, and we can do some different scenarios of that. But it could also mean how much space is in between. And if we think of that contextually with positive numbers, this can be helpful for us too as we're processing through here. So now that we're seeing this, I want to practice this with a few more ways of kind of just seeing what are some ways that I could make sense of this newfound knowledge that I have, this growth that I've been able to have in my own personal life. So I'm going to come into here and say, okay, so if I had a number line like this, and I'm going to put 0 right there, and I'm going to go 1, 2, 3, 4, 5, 6, maybe put a negative 1 there. So I'm going to kind of put a 2 there and a 5 here, and a 3, 4, 5. And again, of course, you can write in all the numbers there too. But I want to kind of take a look at this and say, okay, if there's a black dot here, and if I'm coming in here saying this, I want to challenge myself. I always like to challenge myself and think, okay, how could I think of this? And I could think of this additive. I could think of this as a sum problem. And I could think of this as saying, okay, 2 plus what number is 5? And I could think about it that way. Or I could think about it and thinking about, okay, so what's another way? I could think of it as a subtraction problem, as a difference problem. And I could think of a way 5, or I guess the difference of 5 and 2 is what number? And honestly, however I look at it, I'm going to get the same answer. I'm going to get that same result, and we're going to say that 2 plus 3 is 5, and the difference of 5 and 2 is 3. But we can see that in two different ways, and I'm thinking about, okay, am I thinking about it as adding on a certain amount, or am I thinking about it as finding the difference of? Or I could even go a step further and saying, like, moving left on the number line, that's more of like taking away. But thinking about that flexible idea of what does subtraction mean, it means a number of different things. So let's do one more example here, just with some processing here to kind of say, hey, is this making sense? Is this something we can look at here and say, I'm going to try it one more time, a little more complex, and say, okay, what if we did this, going back to that original problem and saying, okay, so here's 0. Let's call this, we'll go here 2, and then we'll go here just to kind of see where we are, -1, -2, -3, -4. We'll go to -4, sure. And I can come into here and say, okay, so let's say that there's a point here. And let's say that we kind of had that initial starting point. And again, the more that I've thought about this since that first conversation, the more I'm beginning to realize why that initial purple arrow or pink arrow, whatever you want to look at that initial arrow actually is really valuable in this conversation to say, okay, where's our starting point? What are some of the things we're looking at? So to me, I wanted to say this is -4 plus what number is 2. We could think about it that way. That's the way that I wanted to process it. And there's nothing wrong with that. -4 plus what number is 2. And that's going to be totally fair. That's what this is representing. But it also is representing the difference of 2 and negative 4 coming into here. The difference of 2 and negative 4. And I know we talk about like to subtract, add the opposite, or again, sometimes I'll kind of talk about it's the opposite of negative or subtract the opposite of a number. But this is presented in a different way that I really like, and I'm really leaning into this piece, is the difference of 2 and 4 is how much space is between those numbers and how much space is we're thinking about this. So that difference is in fact 6, and that's the difference. And that's another, again, a way that I could think about it. Is it the only way? Absolutely not. Are there other ways? 100%. There's many ways we can process this. But I always find that the more ways that I can conceptualize any piece of math, the more ways that I can make connections, that's going to give me more opportunities to help other students make connections themselves and help them to think, hey, the way that you're thinking about it is relevant, and you're just explaining this, and now I can kind of anticipate what you're going to say next, and we can have some really good, solid conversations. So again, my goal in all of these videos is to help us to understand, hey, I might not know something, but can I help myself to make connections so that I can help more students make connections later? So I'm not surprised when some of those questions come up there too. So hopefully this was helpful to you to think about, hey, what's something we can do to help students or even help yourself understand adding and subtracting positive and negative numbers. There's a whole lot more we can get into. But if this helped you at all, even to move a smidgen on that continuum of understanding and making different connections, feel free to let me know in the comments. If you have other ways to help students understand positive and negative numbers, adding and subtracting positive and negative numbers, different ways, especially if they're contextual, please throw them in the comments. It's always important to kind of see, hey, how can we make different connections? There isn't one right way that we want to say, hey, do this all the time, because the more we do that, the more procedural it becomes, and students don't actually understand what that means. And I'll be honest with you guys, I'm super, super impressed that teacher said, hey, I'm a little bit confused about this. Can you help me out? Because in all honesty, I was a little bit confused by this. And if anyone's confused, we're all probably a little bit confused, or maybe some of us have different answers there too. So we can all learn so much from each other.